Thank you all. My name is Jed Dutton. I am Vice President of Marketing and Sustainability at TemperPak, and I'm very happy to be here. Thank you.
Hey guys, I'm one of the co-founder. I'm Charles Vincent, one of the co-founder here at TemperPak. So we created TemperPak in 2014 to help develop sustainable packaging material that protects the earth and help reduce our reliance on plastic foam. So really excited to be here today with Jed to talk through how to create value using innovative and sustainable packaging. So imagine a world where every package that we ship was volumetrically optimized, and a world where we could specifically tailor the packaging performance to the product needs in real time. In a world where we're producing more value-added good closer to the end customer. That is the world that we believe in. And let's be honest. In the United States alone, we ship about 22 billion packages a year. And on average, each package is only 60% full. So that's like having the equivalent of 140 million cars zipping around the country, delivering air. And just like you guys know, most of the time, those products still arrive to us damaged because traditional packaging material just can't deliver. And then meanwhile, things are kind of heating up, right? Like e-commerce is surging, consumers are demanding more, companies want to lower costs, and regulators want to increase sustainability. So when you add all these factors together, you quickly realize that today's packaging math just doesn't add up. Lower costs usually means less sustainable. More sustainable often means sacrificing performance, and more performance usually means higher costs. So this is the equation we're all staring at every day. Reduce costs, improve performance, and somehow do that with more expensive sustainable materials. And the reality is, traditional packaging materials just won't solve that equation. So unless we want to be stuck making trade-off every day, we need a new framework and we need to rewrite the equation. So let's talk about how we're going to change that equation. It starts with optimizing the what. So we want to develop novel packaging substrate that can do more with less. So think of smarter packaging material where we can dynamically optimize and tune in to the product needs in real time. Then we're going to rethink the how. We've got to rethink the value chain. We need to eliminate the middle mile and producing more value-added good closer to the end customer. And then finally, we need to lean into digital insight. So think of it as every package becomes a data point, and with time, we evolve packaging decision from guesswork into smart work. So by combining all these variables and elements, we're not just incrementally improving the math, but we're rewriting the equation.
Thank you, Charles. So if we're going to rewrite the equation, we want to start with our true north, which is the consumer at home. We need to understand their needs today and anticipate their needs tomorrow, or we're going to lose. Luckily, at a high level, those needs are actually pretty straightforward. For starters, they want what they want, and they want it now. They want it to arrive in one piece, they want it to arrive at a reasonable cost, and they don't want to feel guilty when they get it, right? So the question is, how are we as an industry doing against these very key customer metrics? I want it now. Well, we have analyzed this, and we think that most online orders are fulfilled in about 1.5 to 2 days. There are some corners of the ecosystem where 2-hour delivery is a thing, but for the most part, it's more like 1.5 days or 2 days just to be fulfilled. Now, that's super impressive. Our grandparents would be pretty wowed, but in many ways, it's still faster just to drive to a store to get something. So that's a real opportunity for us collectively to keep working on this system to get even faster. They want it in one piece. Well, it looks like over 800 million shipments need to be reshipped due to product damage. Now, as Charles said, there are 22 billion boxes flying around every year, so 800 million doesn't seem that bad, but it is still a hugely costly problem, both in terms of actual costs and from a brand perspective and consumer trust. I want it at a reasonable cost. Well, we are pretty sure that absolutely no one, except for maybe every person in this audience, wants to see the packaging spend go up in the cost of goods sold. So we know the reality of our industry is packaging needs to not cost very much at all. And they want it without feeling guilty. This is pretty real. There's plenty of survey data that supports this, but we know across our whole portfolio of customers who work in this space, they are hearing that people are concerned about this model of individual items arriving in boxes to their homes every day. Is that viable? Is it sustainable? Well, packaging is really kind of the headline in their eyes, and they're going to make brand choices and purchase decisions based on companies who are delivering a sustainable model. So where does that lead us? Well, unfortunately, we're back looking at this equation, which is still pretty daunting. Charles, you're the brains of this operation. Please give us some good news.
Okay, so we're back here, right? How to rewrite the equation. Clearly, it seems like the old rule don't apply. So let's dive into how we're going to optimize the what. So it starts with the product, and then we work outwards, right? So instead of forcing generic product inside oversized boxes, we want to study their shape. And then we want to create digital twins so that we can simulate virtually before touching any material. And then here's the fun part. You want to play Tetris, right? You want to iterate the form, iterate the fit. You want to eliminate empty space and ultimately eliminate void fill. And shout out to our friends, by the way, at Packurate for leading the charge on that. And then finally, you want to squeeze the content as tightly as you can, right? Remember what I said earlier, 22 billion package, on average, every package is only 60% full. That's the equivalent of 9 billion cubic foot of extra air, or the equivalent of about $35 billion in avoidable freight spend. Now, I will pause here because none of this is new, right? Like there's companies out there like the PacSize and CMC and the Spark of the world. They do just that. But all these companies rely on one thing, and that is they all rely on corrugated. And I gotta say, as an engineer, corrugated is a really good material, right? I mean, it's abundant, it's cost effective, it performs well. But let's face it, corrugated, even today, is still produced centrally. And you simply cannot tune or optimize the corrugated property on demand, on the fly, to the packaging needs. So we thought, well, maybe there's something better. So imagine a world where we upgrade from corrugated to a novel paper-based substrate where we can dynamically optimize the packaging property in real time to match the product need. So imagine a world where you could, on demand, change the thickness of that substrate or the fluting density of that substrate to produce different properties. So whether it's light cushioning application or heavy cushioning application or even thermal application. And then converting that substrate into whatever form that you'd like, whether it's a box or a mailer or fanfold corrugated, and then ultimately produce those solutions on demand using very modular and miniaturized technology. So instead of using different SKUs, right, like a cardboard box and then insulation and then void fill and then dividers, what if we just combine all of those into one substrate? So think of it as like one substrate, multiple function, many form. And we think that that future substrate is within reach. So if optimizing the what was all about materials and fit, rethinking the how is about eliminating the middle mile. So as you guys know, today's supply chain is very produced centrally. We're converted goods very far distances. We're trucking them along to warehouses where we're holding inventory and then further distributing that inventory to the end user. But what if we turn every facility into a micro factory? What if we were able to produce more value-added good closer to the end customer so that we can increase the unit value output per unit area? And that's really the vision behind a more hyper-local, decentralized manufacturing world that's connected as well. And to get there, we need to develop, we need to engineer novel machinery and processes that can be modular in design and miniaturized. So whether it's on-demand manufacturing of insulation, or on-demand manufacturing of gel pack, or on-demand corrugated, what we want to do is design equipment and processes that allows us to take basic universal inputs like water or paper rolls and convert those inputs into multiple different products on demand in the most compact manner. And if we do this right, every time we eliminate a middle mile, we're taking a truck out of the equation. So from a sustainability perspective, this is not just an incremental impact, it's a very transformational impact. This is a great example here. One of our clients, a leading food service provider, they came to us and they wanted to streamline their insulation packaging supply chain. So in the old model, they were receiving one inbound truck a day of insulation. Hi, Natasha. One inbound truck a day of insulation. They had to use multiple different insulation SKU across multiple different seasons, right? So winter insulation, summer insulation, and then shoulder season. And then their consumer were demanding a more sustainable product. So by internalizing the manufacturing of their insulation, the client was able to move from one inbound truck a day to one inbound truck of insulation every 3 weeks. They were able to go from many different SKUs across all different seasons to using only one SKU, like that same paper roll could be converted on demand, on site, into whatever insulation profile they needed, whether it's winter insulation, fall insulation, summer insulation, in a machine that's not bigger than the size of the stage. And then they were able to move from a petroleum-derived product, petroleum foam, to a fully curbside recyclable insulation. So by rewriting the equation, they were able to reduce their costs, increase the sustainability of their product, and doing those two things without impacting the performance of their insulation. Is that it?
Yeah.
I think that's it. So.
Okay, you can leave it there. Okay, so the final piece of this new equation is using insights to do less guesswork and more smart work. So we're talking about pretty familiar concepts here, understanding the requirements of the end user, understanding the performance requirements of the journey, and continually optimizing your solution so it gets better and better and more efficient and more efficient. So we're talking about external factors. So ambient conditions, temperature, shocks, drops, shakes, the physical demands of the journey. Performance factors. So the portfolio of packaging materials at your disposal. How do they really perform on their own and when they're working together? And payload factors. How fragile, how temperature sensitive, the actual shape of the payload itself. So using that insight, but also leveraging the power and scale and precision of digital technology to get smarter and smarter and create a more efficient ecosystem. One that is fueled by a digital platform that can define and identify precisely what solution is needed on a given day for a given application for a given assignment. A local modular manufacturing platform, the sort that Charles just described, that can actually produce that solution and assign it the markers for tracking and performance data that can then fuel that digital platform and make it smarter and smarter. So we like to call that packaging perfection. And we are not there yet, but we are working toward it and trying to apply those principles to our work with clients every day. So one of them is a leading pet food company. They ship premium, nutrient-rich, frozen dog food to customers all over the country in various cities. And they came to us because A, they felt like they were spending too much on packaging because they felt like in many cases it was overstuffed with insulation and coolant and other things to protect the food. But then they also had a pretty high incidence of warm on arrivals and needing to reship due to damaged product. So they said, TemperPak, Charles and your team, can you please help us? And so we said, yes, we can. So what we did was to work closely with them to better understand their shipping lanes, the key shipping lanes for where most of their business was. So understanding their max and min temperatures across seasons in those markets, understanding damage rates per SKU across those markets and across those seasons, and other factors, and help them develop a coolant curve matrix which helped them understand in a detailed level how much coolant they needed for their different size shippers across going to different cities in different seasons. And with this insight, with these insights in place, they were able to save hundreds of thousands of dollars through reduced freight, reduced packaging, and reduced reshipments. So when we are sitting there looking at that math equation and feeling sad about it, this is an example where packaging can increase value and give us some faith and some enthusiasm that we can indeed change this equation by optimizing the what, rethinking the how, and using insights. Charles, anything else?
Thank you.